Let's solve the first problem of the 3n+1. We're going to make a simple change to our code as following. First of all, let's handle the base case. Now, if n equal 1, the base case now is just to return 1. This is the very base case of our sequence. In the second one, we have n modulus 2 equal 0 case, which will need a recursive call to division by 2. For example, if n is 16, then we need to get the answer of 8, then add 1 plus it. If n is odd, for example 3, we need to multiply 3 times the 3 plus 1, which is 10, get the answer of that and return 1. Now, I would like you to remember the rule that I told you about it to trace the recursion in a very easy way. The trick isn't to keep tracing the function. Do not keep tracing the function. The trick is to focus on what more than focusing on how. What does this function do? This function is going to return the answer of the sequence, which is the length of the number of items till reaching 1. This is the what. This is the how. And if you keep tracing every recursive call, you are going behind the how and the how and the how and the how. The trick is to focus more on the what. So now, what does this function do? Let's say input is 16. 16 over 2 is 8. What does this function do? This function is going to return 4. Don't trace it. Then I am returning 1 plus 4. Is this correct? Yes, we are done. Let's say the input is 3. Then we are here. 3, but passing it here with 10. What is this function going to do? Length of 10 is, let's see here, 1, 2, 3, 4, 5, 6, 7. This function call is going to return a 7, and I'm going to add 1 for my sequence to consider this new 3. The answer is 8. This is how professional guys trace recursion in practice. We do not keep tracing recursion. You don't keep n is 6. Now let's call n with 3. Let's call n with 10. Let's call n with 5. Let's call n with 16, with 8, 4, 2, 1. And you get lost among all of these recursive calls. We don't think this way. You focus more on the what and less on the how. Your code is valid if you manage to trace every single call, every single recursive call. If you manage to reach it once, you are sure that your code is going to work well. Please keep this advice so that at least if you couldn't solve the recursive task by yourself, you at least know how to trace it properly without wasting a lot of your time. The second way, if you just happen to get lost with the tracing and you insist on tracing it, then start to put one breakpoint at the the base case, another breakpoints at every recursive call, and just let's run it. We would like to trace 6. So as you see, the first breakpoint is activated as here, as n is 6, 6 mod 2 is 3 is 0. So we are now here. Now with feel free to put also 1 in the beginning of the function. Let's go. Now we are here with the n equal 3. So now it go and go. It's now go on the outside. So the 6 is 3, and 3 will call us with the 10. So now we go to the 10, and so on. So now it's going to be very puzzling for you, as we have to keep going till the base case. Let's close all of these guys for now and go directly to the base case. Now we are at the base case. You see, we have all of these recursive calls. Now let's trace back one by one. The 1 is going to return back to here. This function now returning for me 1. 1 plus 1 is 2. So we'll return the 2 to this function. This function now will return 2 plus 1 is 3, and so on. Now here 3 plus 1 is 4. Here 4 plus 1 is 5. Now we jump here, 5 plus 1 is 6. Also, if you got confused, try to take this in a separate variable here and use it so that it's easy for you to trace it. I hope it's clear how to handle tracing recursive functions.